Hey everyone, today we're going to take a look at scientific notation. So numbers in scientific notation, two examples you see here, are numbers we use to represent either really large or very small numbers. So let's talk about, first of all, how do we know if a number is large or if a number is small? If a number, you'll notice both of these have times 10 to some exponent or to some power. If the exponent is positive, that is going to represent a very large number. If the exponent is negative, that's going to represent a very small number. So for example, this first one, 4 times 10 to the fourth power, that represents the number 40,000. Like an airplane could be about 40,000 pounds heavy. So that's something really big. But if you look at the first one, or the second number, 4 times 10 to the negative 0 power is really this number right here, like maybe the size of an atom. That's something really small. And by the way, the numbers on top, 4 times 10 to the fourth and 4 times 10 to the negative 8, those are in what's called scientific notation, which of course is the name of the lesson. Once we expand it out, like we did on the bottom, that number is said to be in standard form. So what we're going to practice today is rewriting numbers in scientific notation or standard form, or go both ways. So here's how we do it. The first thing we're going to do is I'm going to give you a number in standard form, and we're going to rewrite that in scientific notation. But here's what you need to know. It's always going to be some number times 10 to some power. And I'm going to put a little number sign there for the exponent. The number here has to be 1 through 9. You can't have 12 times 10 to the fifth power or 28. You have to have, it would have to be 1.2 times 10. You can only have the numbers 1 through 9. You can have a decimal with numbers after it, but you can only have 1 through 9 as your first number. So let me show you what I mean. So my number here would be 3 times 10, and the exponent comes from how many places you move the decimal. So right now, my decimal in 3,000 is at the end of the number. But to rewrite it in scientific notation, I'm moving it here. So that's going to be 1, 2, 3 jumps. So 3,000 in scientific notation is 3 times 10 to the third power. And since this was a large number, my exponent is positive. So let's practice a few more of these. We're going to write big numbers in scientific notation. So let's look at the next one, 32,000. So first I need to find my decimal. My decimal is here, but it has to be here. I'm going to move it here to write it in scientific notation. So that's going to be 3.2 times 10 to the, let's see how many places I move it. 1, 2, 3, 4 to the fourth power. So 32,000 in scientific notation is 3.2 times 10 to the fourth power. Remember, numbers that are really big, usually they have the zeros on the right side, have positive exponents. Let's do 2 more of these really big numbers. So I want to write 321 billion as in scientific notation. So let's look at where we're going to move decimals. Our decimal is here. We want to move it here. So this is going to be 3.21. We always are going to have times 10. And the number of spaces we move is our exponent. 1, 2, 3, 4, 5, 6, 7, 8. And since it was a big number, it's going to be a positive 8. So 3.21 times 10 to the positive 8 power. Let's do one more like this. So let's say we have 9 million. And let's write that as as a, or in scientific notation. Right now, my decimal is here. I want to move it here because I want a 1, 2, 3, 4, 5, 6, 7, 8, or 9 in front of the decimal. That's our goal every time. So this is going to be 9 times 10. Times 10 is what we always use for scientific notation. And I moved the decimal 1, 2, 3, 4, 5, 6. And it's going to be positive because it's a big number. 9 million is a large number, so my exponent will be positive. So now let's deal with some really, really small numbers. Let's look at a few examples of really small numbers being written in scientific notation. So let's write this number right here, 0.00008 in scientific notation. Now here, I see the decimal. It's right here. But remember, for scientific notation, we want to have either 1, 2, 3, 4, 5, 6, 7, 8, or 9 in front of the decimal. So I'm going to move the decimal here, so 8 will be in front of the decimal. So this is going to be 8 times 10, and let's count our spaces. We moved 1, 2, 3, 4, 5 jumps, but 0.00008 is a really small number. If the zeros are up front, it's a small number, so my exponent needs to be -5. So that number written in scientific notation is 8 times 10 to the -5th power. Let's practice some more of these. So let's look at number 6. So I want us to write 0.000843 in scientific notation. Let's find our decimal and decide where to move it. So it starts off here, but I'm going to move it here because I want, remember, 1, 2, 3, 4, 5, 6, 7, 8, or 9 in front of the decimal. And I've got 8 in front of it. So this becomes 8 point, and you write everything else after it, 8.43. See, I didn't just get rid of those other numbers. They just go after the decimal. 8.43 times 10 to the, and let's take a look at, oops, sorry about that, how far we move our decimal. 1, 2, 3, 4. And since it's a small number, it's going to be a -4. Now from here on out, I'm just going to stay in black because I've shown you pretty much what's going on. So let's do a couple more examples of these. Let's change 0.002 into scientific notation. So my decimal is here. I want to move it here. So I have 2 in front of the decimal. So that becomes 2 times 10 to the 1, 2, 3, but it's going to be a -3 exponent because that's a small number. 0.002 is a really, really small number. Okay, let's do one more of these, and then we're going to go the other way. So for this, let's write 0.021439 in scientific notation. My decimal's here. I want to move it here. Okay, so this is going to be 2.1439 times 10 to the 2 power. So that's how we go from a number in standard form to a number in scientific notation. Now let's go the other way. So here we're going to go from the scientific notation to a number in standard form. So let's do the first one, 7 times 10 to the 3rd power. So a couple of things you have to decide or do. First, you want to write the number that's in front of the times 10. Whatever it is, you write it. The next thing you want to do, if you don't already see the decimal, write the decimal. Okay, I'll do that in black still. Next, you want to look at your exponent. The exponent is going to tell you how many times to move your decimal and in what direction. So my exponent is a +3. Remember, 3 is represents positive exponents represent big numbers. So that means I'm going to move my decimal 3 spaces to the right. So watch this. Here's 1 jump, 2 jumps, 3 jumps. So now My decimal is over here, and you fill in those empty jumps with zeros. So 7 times 10 to the third power in standard notation is 7,000. Now you don't have to clean it up like that. I'm just going to so you can see what the final number looks like. Let's try some more. So let's look at number 10. We have 7 times 6, or 7.6 times 10 to the positive fourth power, or times 10 to the fourth power. So first, write your number in front of the times 10, so 7.6. I already see the decimal, so I don't have to put 1 in there. And my exponent is positive 4. Remember, positive exponents represent really big numbers. Another way I think about it is positive 4 is to the right on the number line. So I'm going to make 4 jumps to the right. 1, 2, 3, 4. So my decimal is now here, and I fill in those dips with zeros. So my number in standard form is 76,000. Let's do a couple more of these types. Let's write 9.21 times 10 to the fifth power. Let's write our number that's in front of the times 10. I see the decimal, it's right here. I have a positive 5 exponent. Positive 5 is to the right, because it's a big number. So I'm going to jump 1, 2, 3, 4, 5. There's where my decimal is now. And remember, I fill in the empty dips with zeros. So this number in standard notation is 921,000. Number 12. Let's write 2 times 10 to the 7th power in standard notation, or standard form, I'm sorry. So first you write the number in front of the times 10. I don't see a decimal, so I'm going to add a decimal at the end. That makes sense. 2, it still is 2, it just has a decimal. I have a positive 7 exponent, so that means I'm going to move 7 spaces to the right. Positive exponents make numbers bigger. So I'm going to jump 1, 2, 3, 4, 5, 6, 7. There's my new decimal, and I'm going to fill all my dips in with zeros. 1, 2, 3, 4, 5, 6, 7. Yep. So in this case, 1, 2, 3. My number in standard form is 20 million. Let's look at what happens when we have negative exponents, how we change those to standard notation. So we have 9 times 10 to the negative third power. We still write the number that's in front of the times 10. However, I will give you a little bit of caution. Negative exponents mean we make the number smaller, so we move the decimal to the left. I'm going to write my number over here because I'm going to be adding zeros in front of the number. So I look at my exponent, it's negative 3. Remember, on a number line, negative is to the left, and moving to the left makes the number smaller. So I'm going to move 1, 2, 3 jumps to the left. I'm moving my decimal. So this number in standard form is 0.009, and some people add a 0 up front in front of the decimal. Okay? Number 14. Let's change a few more of these. So 9.4 times 10 to the negative 5 power. I do notice there's a negative exponent, so I'm going to write my 9.4 over here a little bit. How far do I jump? 5. Which direction? Negative is to the left. We're going to make the number smaller. So 1 jump, 2, 3, 4, 5. There's my new decimal. See, I'm going to mark the old one out. Fill in my dips with zeros. So in standard notation, my number is 0.000094, and I do like to add that extra 0 in front of the decimal. Let's do 2 more examples. 15. Let's change 8.23 times 10 to the negative fourth power into standard notation. So first, I notice I have a negative exponent, so I'm going to write my 8.23 over here. Negative 4 means I'm going to jump 4 spaces to the left. So 1, 2, 3, 4. There's my new decimal. That one's moved. 1, 2, 3. So in standard notation, or standard form, 0.000823 is our number. And let's look at one last example to help you with your practice. Let's say we have 5 times 10 to the negative 6 power. I do notice I have a negative exponent, so I'm going to write my number over here. I don't see a decimal, so you add 1 at the end. And now let's decide which direction and how many times I'm going to move my decimal. Negative 6, negative is to the left because it's small numbers, and 6 jumps. 1, 2, 3, 4, 5, 6. Let me fill all those in. So in standard form, I have 0.000005. So be sure to use your notes to help you with your practice, and I'll talk to you all